So functions, scope. So this concept of scope, there are two things called as local and global. What are these scopes and how we can work with it? So basically you need to understand one concept, that in functions, in Python, there are two built-in functions called as global. If I say globals, okay, this is a function. If I ask, it will say the global things about this function. In the script also, I can ask the same thing in Jupyter Notebook also. In a Jupyter Notebook, see here, what is the name? What is the document? So means this is a typical IPython notebook, right? So it shows like this. In the same fashion, I can ask for something called as local, and you can ask. You see, for the locals and globals, you get the exact same values. So whatever you got for the globals, the same thing you got for locals also. But so in input, you got like locals, globals function also. Means whatever is there, it is coming as it is. What are these two functions? How they can help us? Let me create a small program, okay? See, globals, locals, scope, right? Scope.py. Now created a .py file. Within that also, I will print, hey, print globals. Maybe like I can use an f-string assignment. Within that, I can ask, hey, what is globals? Is equal to. It's a function with nothing, just because only one that function. Now, when you are executing, I navigate to the directory or give the entire path. Either is fine. So if I say Python space, the entire path if I give, if I execute, did you see it is saying this is the globals? Generally, globals is like a dictionary. So if you want to better print them, from pprint, import pp. So instead of an ordinary print like this, if I do pprint of globals, you can better see the output. So if I clear the screen, and if I ask again, you see what happened? It is saying name is equal to main, documentation is nothing. So you got something. Means the answer that you're getting on a Jupyter notebook, and here is different because every environment once created, it has some metadata. That metadata you are getting. So in a Jupyter notebook, you will get more things. That's the only difference. Similarly, like pprint, so of globals, I am asking for something called as locals. Maybe I'll write a print statement that, hey, so locals. So like this. And similarly here also globals. Maybe one empty print statement in middle just to show the difference. If I clear the screen and if I ask again, did you notice the globals and locals were exactly giving the same values? So fine, but a lot of things which have underscores on either side means these are something related to the metadata about the program. But you have never created anything. So now let me create a small variable. Say number 1 is equal to 100. I created. Now if I clear the screen and if I ask again to print it, did you see that? Ignore the things which have underscores on either side. Focus. You have number 1 is equal to 100. Here also number 1 is equal to 100. So means like when you create a variable, it is coming to both the scopes. Then what is the difference, sir? In which case we need to go for local scope, in which case global scope. First of all, what are these scopes concept? So if you, for every function, if you are asking outside functions, it is showing like this, right? Let me define one function. Define my function. I'm not doing anything, but within here also that I am printing, within function also. Say within function. Within the function, I'm asking to print, hey, what are the globals and what are locals? And I'm asking like, hey, my func. I'm making a call. Now observe carefully the difference. If I clear and ask again, did you notice? So outside things are the same. Okay. So within the function, did you see the difference? Within the function, when you asked, hey, what is the globals? You got the same thing. Whereas within the function, if you ask what is locals, did you see you got empty? This is what you need to be aware of. Means locals and globals are two functions which will help us to understand what is the scope. If you define any variables at the global level, means at the script level, those will be available everywhere. That's the reason global scope is available here also. Whereas local scope means local to something. So that's the reason local function should not be called in the global scope. It should be useful only within the functions. Means for every function there will be own context and own values. Say within the function I assume that I am defining some number 2 is equal to some 300. So maybe like I'll place here itself something. Now observe carefully. If I ignore these things, you know already that I can ignore that noise. So if I ask within the function as you define, did you understand that within the function you have number 1 is equal to 100 within the function when you're calling? So did you see this number 2 is equal to 100 was part of the local scope or global scope? So this number 1 is equal to 100 only came here, including your pprint import, everything came in the global. Means whatever you defined within your function, so within the function will be coming at the local scope. Number 2 didn't come here, right? Whereas if you define even number 1 is equal to some other number, say like 200 I give. So number 1 is present both in the local and global. Number 2 is present only defined locally. Now in this case, if you see, observe carefully what happens. In the global scope, whatever you define the global variable, only that is there. Whereas in local scope, whatever the variables you defined within it will be there. Means, did you see, observe carefully, number 1 is equal to 100 in the global level. That's the reason in the global scope, number 1 is equal to 100. Even if you ask within the function also, the global scope value is like that. Within local scope means within this function only, number 1 is 200, number 2 is 300. Means once you come out of this function, if you ask here what are the locals, if you try to print, it will say nothing. Means what are the things that you define within the function cannot be taken outside. They will have their scope only within them. Hope you understood what I am trying to say. Scope means when you define a variable, till what it will have its impact. That is the scope concept basically means. So till what it has its effect, so that we can see. Okay. Excuse me. Yes. So now we understood this concept. So one more simple example I want to bring to your notice is that, okay, we understood these concepts. So let me comment them. Now I'm asking, you know, globals also give some values, locals also give some values. So what I'm trying to say, at the global level, means at the script level, so globals will give some values, which is a dictionary. Similarly, locals also will give a value, which is a dictionary. I am saying an assert because at the global level, both are equal. If you go within any function, then so assert globals is not equal to locals. That's it, right? So locals of any function will be locals to that only. So globals will be globals to that. So that is what you should be aware of. Hope this much is clear, right? So this is what I want to prove till now. So now what else I want to do? Let's see. I want to work on some use cases to help you understand something interesting. As this concept of locals and globals came to picture, Now, there will be two things that you should be aware of. Generally, this is the most important point if you are learning any functional programming language. So, if you go to the concept of Python, Python supports two things. One is call by value and other one is call by reference. What are these call by value and call by reference? How they can help us? So call by value means any function when you are working, so how much it can help. If the changes within the function were not reflected at the global level, those are called as call by value. Means you passed value to any function, what are changes happens within the function, so we don't have any problem, it will not come outside. Whereas if what are the changes you're making within the function were having an effect outside also, that is call by reference. So primarily Python supports both the things. So what I'm trying to say, Python supports depending upon the object type. Means generally if you go for other languages, they support only call by value or only call by reference. But Python supports both the things. So how it supports means it depends upon the data type. Primarily, I told data types are two types. One is mutable and immutable, I told. What is an immutable means? Any object that supports changes on itself is called as a mutable object, which we have already seen like list, set, dictionary, byte array strings like that. Whereas immutable strings objects means they doesn't support in-place changes. So that's a difference. So what they are saying is that conclusion is Python supports mutable objects and immutable objects. For mutable objects, by default it is call by reference. Whereas immutable objects, it is call by value. So how it supports, I told some theory. Now I need to prove itself that it works like that. So how do I prove? Let me take examples one after the other. So in first use case, let me take a simple example. So let me go with the very first example. Here I want to say like pi is equal to 3.14, which is a immutable object. So 3.14 means it's a floating point value, which is an immutable value. So I'm saying for immutables, it is call by value. Call by value means what? What are the changes you make within the function should not reflect at the global level. So fine. First of all, I defined I defined a function. Within that, I'm using the value. I'm taking pi and pi into 12. I'm multiplying. So fine. And within the function, I can ask what is the locals also, if you need. First of all, this is a strange case. Till now, I think like C++ or somewhere else, if you see, if you define something and if you are not using them, then it will throw an error, right? So now in this case, will it throw an error or it will work? So that's what we should be aware of. Now, you defined a variable outside and you are using within the function. Will it work? It didn't throw error because we didn't make a call. Okay, I'll make a call to this. So let's see. If I make a call, it should execute. Now, did you see? You defined a variable outside, but you didn't pass as an argument, but you used within the function. It is working perfectly. Now, if you want to see what are the locals within that function, so we can ask, hey, what are the locals? So you can ask, hey, what are your locals within your function? If I ask, it says that, okay, I can ask for ordinary print also, right? Because it will not have much values. So print of f of locals is equal to, okay. You see now what happened? So locals is empty because within the function you didn't define anything. But this pi, whatever you got is a global scope. So that is what you are already aware of. So fine. So you are using the global value, but it is working. So in the first case, without passing any argument, you are able to use within that. Now let's go for the second case. This time, what I want to do is like, I want to modify it. Means I still don't want to define. I'm using the same kind of thing which you have defined outside. Maybe like if you want, I can write again. So I defined the variable outside and I'm using within it. Till now I'm just using it. I'm trying to update the value. Means what are the value which I took, which I want to update. So, and let's see if I make a call, will it work or not. So if you execute right now, it says that, hey, local variable pi referenced before assignment. Means, so whenever, so global variables, we can use without even passing to an arguments. But if you want to modify them, first they should be defined. Without defining, if you are trying to modify it, then it will be an issue. Means without, if you are just using it's fine. But if you want to modify, first it should be defined. Either defined means what? Before using it should be defined, or it should be passed as an argument. That's what this unbound local error means. This is a very interesting point. So now you understood that whenever you want to use, you can use global variables. But if you want to change, you need to first define. So this time, what I took is that I passed this value as an input to it. And I want to use. And you know, these locals and globals will have a lot of values. I don't want too much noise. That's why in the dictionary, I'm asking for this value. In a dictionary like this only, right? We will index. So I defined as an argument and I'm using it. So when you have defined as an argument, so can I call without arguments? If I make a call, say simple function without arguments, this also will throw an error. As you know that, whatever the value you pass, the same thing we need to use, right? Maybe like the same pi which I defined outside, I'm using it. So whatever defined I outside, the 3.14 something, the same pi value. Either I can write pi or like 3.14, whatever. So whichever I am comfortable. But the best practice they say is that whatever you are using outside variables, don't use in the same function definition also same variables, because it will confuse you. It's not a mandatory, but it's best practice. So if you use also fine, nothing will happen, but just it will help you understand. So if you see now, so globally you define 3.14. So locally within the function, before you changing, you asked, it's a 3.14 and you change it to something else. After changes also you asked, hey, what is the value? Fine. So within this, it has two things. One is global scope and local scope. Local scope has a value of 3 point so and so. Global scope has a value of this thing. Global means anything outside the function is global. Within the function is local. So within the function you changed. So now will that change reflect outside? I'm thinking. No. Means what we can understand. So what are the changes you made within the function were not reflecting outside? With this, what we can conclude? So changes within the function were not reflecting outside. So don't you think it's call by value? So this is what call by value means. So what are the changes you made within the function were not reflecting outside? So with this, what we can understand is that for immutable objects, what are the changes you make within the function will not reflect outside. So it is call by value. Okay, sir. What if I want to make a call by reference? Means what are the changes I want to make that should be reflected outside? So basically for immutables, it supports two ways, both call by value and call by reference. So by default, it is call by value. But if you want call by reference, means what are the changes you make within the function to reflect outside? There is another case where I need to define the argument, whichever I want to pass, as a global. This is another thing that you need to be aware of. So this may be surprising for you, but this works like this. Till now, what are the variables you are using? You didn't define earlier. You just used as it is. So, but this is the first time you are defining. And observe, it is not globals. No, yes, it is global. So global is a keyword Globals is a function. If you see in our list of all the built-in functions and the keywords, you can understand that. In the built-in functions, I told almost all of them. So, but like you see, the globals is a built-in function. Whereas in the keywords list, I told there is a global keyword, right? So global keyword is different, globals function is different. So if you want to make local changes to be reflected outside, you need to make as a global. So, but one thing you need to aware is that whenever you define some variable as a global, then you should not pass as an argument again. Means anyhow you are getting the variable from outside. Then why do you want to define? So this is what you should be aware. So the most common problem that people face is this thing. So now in this case, what I will do, I will define the variables, whatever I have. Okay. So I am asking here, what is the value of global and what is the value of local? So I pass like simple function. For this function, I need not pass any argument. What are the global value of pi, which is 3.14, the same thing will go. Now we see if I execute. Did you see within the function, I didn't pass any argument. So, but I can modify within it. So I told that when you are modifying within it, either it should be passed as an argument or it should be defined. Defined can be like anything. Locally before defining, you can define, or global definition is also one kind of definition. So means like global value it is getting. So you see, now if I ask, hey, what is the value of pi? It will say that pi value is so and so. So did you see that pi value was changed now? Whatever the changes you did within the function were reflecting outside or not? Now to consolidate again, so I'm rewriting. So you told again the same thing, pi value is equal to 3.14 and you are passing as an argument. And see here, I am asking here what is the global variables and local variables of pi. See, till now you should have pi, right? Let me get the entire pi. So locals, okay? So I will tell you. So I'm asking to print both the locals and globals. Globals has too many things. I want only the pi value, but locals I want this thing. And outside function also I want to reflect. All of them in one place. If you see now, initially value of 3.17 and you made changes, it was so and so. And did you see, though you defined the variable pi is equal to so and so, locals is empty because whatever you defined was related to the global scope. Means locally you didn't create any variable. So that's why it will become empty. Whereas in global, the pi value will be there. What are the changes you make will reflect at the global scope. That's the reason outside function also if you ask, hey, what is the value of pi? It will say so and so. Now with this, what we can conclude? So for immutables, there are two ways of doing the things. For immutables, by default, it is call by value. Means what are changes you make within function will not reflect outside. But if you use the global keyword, it becomes call by reference. Now it is fine. Similarly, if I want to work on the call by reference for the mutable objects, that we need to see. So if you see now, in the same fashion, we can go for a call by reference for the mutable objects. For immutable objects, you have like this. So but for mutable objects, then what is the scenario? Mutable objects by default it is call by reference. Means what are the changes you make within the function will reflect outside also. So means let's say I took a dictionary. Mutable objects means I can take a list or a set or a dictionary. I took a dictionary, one of them to help understand. Now for this function, I will take a simple function and I'm defining and I'm asking, hey, what is the value? So I don't pass any argument. I will ask like a simple function and make a call. So I'm not making any changes. So, and I'm first asking. After that, I will make a changes to it. Within this details version, I change to something else. Maybe like now the version is 3.12, I'm changing. And I'm asking. Now you see what happened? From 3.7, it changed to 3. So and so. Now, whatever the changes you make, we want to check whether it reflected outside or not. Now, after this function, I'm asking. So you see what happened? Outside the function, version is equal to 3.12. Means what are the changes you make within the function were reflecting outside or not? Yes. So now I want to check what are the local scope and global scope. I told that locals function, if you define outside, it makes no sense. Generally, locals function we need to define within functions only. Now I want to check within the locals whether it creates anything like a details or not. So when you are not defining neither in the arguments or here, and if you are just using the outside argument, you get the global scope as it is. But did you see that locals will not get anything? There won't be a key called as details. So no details, dictionary will be defined inside. So means whatever you understood, without defining, you are using within the function. So what are the changes you make to the function will reflect outside. Sir, is it an advantageous or it's a dangerous thing? In fact, I would say it's a dangerous thing because whatever the changes you make outside will reflect outside directly means. So don't you think like it's a bad idea? Okay, sir. So now understood. To some cases it's okay, but like to majority of cases it's not a good idea. Ch- Changes were reflecting outside without you making means that's a big thing. So maybe like I will take one thing. I'll pass as an argument and let's see how it works. So in another case, I will take the same value, same details. I want to take, okay, details I wrote. But within the function, when I'm defining, I will define like in one argument called as language details. So instead of details. So I am making changes to it. So within the function. So within the function, I'm asking. And like outside the function, I'm passing as an argument. Outside the function, I'm passing this what are defined as an argument. So within the function also, I will ask. So instead of we changing with directly, I will say like, language details. This language details I will change. So after the change, I want to check, hey, what is the value? Now you see, what is the value? Now, if you see, I defined the function outside and passed as an argument and I'm changing. And during the argument also, it's a best practice to write a separate name, right? So I wrote it and I'm marking a call. So now did you see what are the changes you make within the function will reflect outside also. To prove that I need to make a function call outside. And you see now, did you see what are the changes I made? So within the function were reflecting outside also. If I make like some instead of 10 dot so and so, if I say 10.12, did you see outside also 10.12k? Means sir what? By default, functions will happen like this only. So don't we have a solution for this problem? So then what is the solution for this problem? So first of all, will the global create anything? So or like will there be anything locals here? So if you want to check that f of say I want to check what are the locals getting created here. We know what is the globals, but what is the locals creating here? Local has like a definition of something. You made changes to local only, but still you are getting the changes reflecting outside. Then what is the problem? So to understand more, I will try to give you the address location of the objects. I'm asking address location of what are the details I got at the global level and the value. At the same time, for the locals, for local, it created a dictionary you told, right? So lang details. For that also, I'm asking for these two, hey, what are the values? If you see now, you'll understand. So both, did you see that address location is same. Means when you pass as an argument also, what are the changes you make within function were reflecting outside. So then like what is the solution, sir? So this is not a good idea, right? Now, so you don't want a call by reference. You want a call by value. So let's see how we can make a call by value. So by default, it is call by reference. If you want make a call by value for these things, now a slight change I will make. I will take the same data as it is. So same data as it is. For within the function, I am defining lang. So you define with some other variable, that's fine. But is equal to copy. I'm making. So the moment I made a copy, it will create a local copy. Now we see what are the changes you make within the function were not reflected outside. Did you observe the address location is different? So whenever you are going for a multiple dimension, so in that case, we need to give that the same way. Hope you understood what I'm trying to say. So for mutable objects, by default, it is call by reference. Means what are changes you make within function will reflect outside. If you don't want like that, you need to make a copy and work on it. So what are the copies that you make will not reflect the outside. So in the same fashion, if I want to explain the same thing for a ordinary, one more example. So if I take example of a list, then you'll understand. If I take one list, my list equal to so and so, and I'm not passing as an argument. I'm making changes locally, and I'm asking. You see, it is call by reference. Means whatever the append I did will be reflecting outside also. But for the same thing, if you don't want these changes to be reflected outside, so what we need to do, even if you pass as an argument also, so it will do the same thing. If you see the same example, if I slightly modified, so earlier I didn't pass as an argument, I used a global directly. This time I'm defining with the same name and I'm making changes, like I'm appending a 5. Now you see what will happen. So what are the changes you are doing were reflecting outside also? Means it doesn't matter whether you define with the same name or different name. So it will work like this. Then if you don't want changes to be reflected outside, then what is the story? So you need to define them as like a copy. For mutable objects, that's the best strategy. If I do like, say 10, so if I want like call by reference to a call by value, so simple thing. So my list is equal to my underscore list dot copy. This is the most important point you need to be aware of. If I do a copy, see whatever the changes I did within the function were not reflecting outside. So this is the most important thing that you need to be aware of. So similarly, if I go for one last thing, so yeah. So what if I made this one? This is one of the interview question which was asked. So they asked like this: hey, you define a variable outside. You didn't make like a number equal to, but you did a new list plus equal to so and so. But generally, if I do a plus equal to means what? You are creating a new list and assigning this value plus that one, right? So in this case, what will happen, sir? Will it create a make changes a new one or like how it works? You see, what are the changes you make within the function were reflecting outside also? So that's what this is one of the very interesting interview questions. So that you should be aware of. And also you remember, so copying can be done in multiple ways. So copying can be done so like this dot copy, or there is another way of doing the dot copy. So instead of a copy, I assign to a new list and I'm passing like this colon, like this colon equal to means I am taking a copy of it and I'm assigning. Now, did you see what are the changes I made within the function were reflecting outside also? Means copy is the best way of doing. If you do in like any other way, it will make an effect. So now to conclude, like instead of making too many things, I can say that for immutable objects, by default call by value. So with global, we can make a call by reference. So that is what we should understand for immutables. But like for mutable objects, so by default, so it is like call by reference. So create copy of value if you want to make a safe copy. So call by value means both support both, but it's up to you like how you want to use it. So whenever you're using, so you need to be aware of this point. Next, so Python has this concept of scope resolution. Now we understood this concept of local global. So are these the only two things? But still, if you see in Python, there is a concept of scope resolution. Scope resolution means in Python, not only these two, there are like two more also, which are supported. Means whenever you are working, these four you need to remember. You need to remember this word called as LEGB. So, okay, don't think about another acronym. It's very simple. So, local, enclosed, global, and built-in. Till now, we know local, we know global. What is this enclosed? Built-in, you can understand. Anything which is built-in. So, true is a built-in object, right? So, what are you give? So, it will give its value as it is. So, if I take like a code object, and if I say true, it's built-in. So, whether you ask in any way, it will tell the same. But if you ask it's TRUE, it's not a built-in. So means some way we need to define to use it. So built-in scope. Built-in scope doesn't mean like this only, or like if you define some variable like, so from math I imported pi. If I ask, hey, what is the value of pi? So then that is also a built-in scope. So built-in scope. So what are you define like this? That's a built-in scope. And similarly, if you define something, so outside the functions, that is a global scope. Outside the functions, if you define anything, that is a global scope. And within the functions, if you define, that is a local scope. I think like pretty much you are clear about these three now. So you learned a lot about the global scope and local scope. Local means for every function, there will be a local. That we know. Now, what is this concept of enclosed and others? That we will see right now. So enclosed means what? So you enclosed with, say, I took away values like this. So you remember it's a comprehension. So for pi in 1, 2, 3, so give the value of pi. Means what is the value of pi each time here? First time the value of pi is 1, second time value of pi is 2, third time the value of pi is 34. Now, so each time value of pi will go, right? But what are the pi value that you are getting? That is confined to that, braces only. Once you come outside and ask, hey, what is the values? What are the values? Okay, values and what is the value of pi? It will say that. Of course, I need to make a call, simple function. You see now what will happen? So what is the value of values? 1, 2, 3. Each are the values. But what is the value of pi? The last value of pi is 34 within the braces. But once you come out of it, you don't know what is the pi. So what are you defined before it? That's the same. It is 333. So don't you think you are getting the same? So that is what I am trying to say. So when you ask the globals, maybe like I write in another way, so you'll understand. So maybe like I say from pprint import pp. pp if I give, you'll understand. So what's the value of pi? You got the same thing. So whatever you define within the local scope, you got the same thing. That's a local. So if you ask the global, it has a hell lot of things because it's a Jupyter notebook, but the pi value would be 3.14. So built-in means like whatever is defined within the system. So that is called as a built-in. So whatever you define globally means outside the script is global scope. within the functions is local scope, and within the this braces is called as enclosure scope. So earlier in Python 2, if you do like this, it used to have a leakage. After this, if you ask, hey, what is the value of pi? In Python 2, it used to say pi value is 34. Because this value used to update on this value. So, but now in Python 3, so that's not the case. Whatever you do within it will not reflect outside. This is the most important point. So these are the 4 scopes that you need to be aware of. So, and outside the function, if you ask, hey, what are the globals? It will say that it has the global scope of all the values. Now, going further, let's go for the next another functions. With functions, we can do a lot of things. We have seen different kinds of functions till now. So the next important things I want to say is about partial functions. What are the partial functions? How they can help us? Let me take a simple example. I have one ordinary function, which is a multiply, which is taking 2 arguments, so x and y, and it is executing. So if I give like 3, so once I define, I'm making 3 calls. Generally in Python or any other language, whenever you do the say multiple tasks, they say for what is repetition and try to optimize. Did you see in these 3 calls, is there anything common? The first argument is common, right? So whenever you have a scenario like this, so what you are trying to say, hey, every time I want to multiply, but I want to multiply with 2. So in that case, why can't you create a partial object already? So from functools, there is something called as functools. So functools is a module. If I import, I can do a lot of things with that. If I do like a dir of functools, you can understand. It has a hell lot of things to do, but not everything at this moment. As we came to functions, we can do few things. And subsequently, when you go for decorators and others, I can tell a lot of things. But for now, we can use this partial. So what is this functools.partial? If I go on like help of functools.partial, so there is partial method also. When you go for methods, means classes, I will tell that. Here only method. So functools.method, it is telling a lot of things which you cannot understand. What is it saying? But because still you are not into classes and others, but simply how to use it. So you understood that in your primary example, you have first argument is common in all the cases. So I will take that example as it is. In these examples, every time multiply I am taking. So multiply and 2 are the 2 arguments. So a function and 1 argument you want to bind. I will bind together with functools.partial. Did you understand? A function we can wrap with 1 or 2 arguments. So 1 argument I wrap. Maybe right, I will say multiply 2 is equal to. So what will happen with this multiply 2? If I ask, hey, what is this multiply 2 and what is the value? You can see that multiply 2 will give the value in the same way. Did I miss any brace? Yeah. If you see multiply 2, it is saying like it's a functools.partial so and so. Now what I'm trying to say, if I make a call like say multiply of 2 comma 3, or if I make a is same as, so multiply 2 of 3, so both will be exactly same, so both will give the same thing. So whenever you have one of the functions, so like this you can use like that. So if I ask like this asserts, if they are wrong, it should throw an error, right? So in fact, like these partial functions, you can ask, hey, what are the arguments you have, the default argument you have? So it has like 2. So if you ask from which function you are created, you can ask like that. Similarly, let me take one more example. This time, say I have a multiply function like this. In this case, you observe the first argument is different, but the second argument is 2 every time. So maybe like you want to create a func tool. So with like this. Now you have what is the function? Multiply. And what is the argument that you want? 2. These two you want to bind. So you can say like functools dot partial, and maybe you can assign to something like multiply 4. I assign. Now if I do, in both the ways it will work in the same way. So 12 comma 14 or like multiply 4 of 12. So both will do the same job. So if you ask, so it will work perfectly. No error, right? With this, I've proved that things are fine. And also for this function, what are the partial object you created? You can ask, hey, from which function you were created? So what are your arguments? So what are the keywords you have? So like that. Here, I didn't give a direct argument. I said y equal to 4. So if I do by default a 4, it will take the first argument. But if you want like a specific argument, you can give that. In the earlier case, when you have bounded and created, you just told 2. That's the reason when you asked, hey, what are your arguments? It said 2. But in this case, as you did y equal to 2, if you ask, hey, what are your arguments? It said nothing. So whereas if you ask keyword arguments, it said yes. So when you have a function with multiple arguments, and if you want to create a partial object, with some of them, you can do it. Take an example and you take an homework where like you want to create with multiple arguments. You can do on your own. So, or like you take one example like this, see here. I have a function which is taking 3 arguments and doing it. And I'm creating one more function which is taking 1 argument and the other y equals so and so. I did like a f partial function of f comma, so the other 2. So then like I did like from I am passing that partial function to g. So somehow, it's a kind of, confusion. Don't worry. It's nothing to complicate you, but I'm trying to help you understand. So not only this, we can apply these partial functions on any function, even the built-in functions. If you know, int is a built-in function, right? So int is a built-in function. If you pass like a 2 or like 10 or something, it will execute. If I say like, 12, I get the value. But if that's for the same int, if I say 12 and if I say base, I should say give the base as something, right? So if I say base 2 or something, it will think like what is the value? I think like 0, 1 something. 0, 1, 0, 1 something. If I say base 2, it will execute. This is a ordinary int function. But if you want to create a partial function for this, so maybe like I want only for the base 2. So then I can create like this. Base 2 is equal to functools dot partial tools of int comma base equal to 2. So then I can add even a documentation also for it. Like, hey, what is your documentation? Like this. Now, generally, if you want to do, you do like int of so and so, right? So now I can do like a set of which is same as base 2, which is a function we created. So for that, you pass the same input. It will do the same thing. Means like you are creating a mimicking and creating another function. Same like this. So maybe like, I want to create one more example. Say like this now, if I execute. So both will work in the same fashion. And in the same fashion, so if I want to create something for a binary, so if you have like a bin function, bin is a built-in function, binary. If you give any number, it will give the binary version of it. So if I want to create, so I can create. Partial function doesn't mean it will take an argument every time. We can create another function. Without an argument also I passed. And I created my own function. If I execute, it works perfectly. Hope you understood. So with this, take an assignment. So to do a similar operations. So for a calculator, take the example of a calculator, and for calculator, try to implement the same things. So this is an assignment which you need to complete. So develop a calculator which will do all the operations like addition, subtraction, so and so. So make use of partial functions to optimize the solution. So I told you, partial functions doesn't mean we should pass an argument. Even without arguments also, I shared you how to do. Things are working. So one more practical example of partial functions is whenever you're creating the Euclidean distances. Hope you remember Euclidean distance means from in Cartesian coordinate system, we calculate the distance between 2 points, right? So generally, if you have a function, so you have a function which will do like that. Maybe like you take 2 points, and for those 2 points, you calculate what is the distance between those 2 points. So this is how you calculate, right? So generally, if you pass any argument, it will do the calculations for those values. You see, in these examples, you will notice that you gave 2 points. Between these 2 points, what is the distance? It is calculating. Between these 2 points, it is calculating the distance. So, but did you observe that in both the cases, you are calculating from 0 onwards? So means one of the point is 0, that you understood. Then I can create a partial function from it. Say functools.partial of Euclidean distance and one of the points I give. Now 0 Euclidean means by default the one of the value is 0. So then like you can do it. Means on top of regular functions you can create this kind of secondary functions which can help you solve your problems. So this is all about lambda functions which will mimic the existing functions so to help you work. But at the same time there is another kinds of functions called as lambdas. This is the most useful thing. So many languages inherited this concept. I'm not saying Python is something new for it. There are other languages also have. But Java, language like Java recently introduced, I think in Java 19 or something, these lambdas, which were not there earlier. So lambdas are so comfortable. So lambda, the moment we utter, people will confuse between AWS lambda and like Python lambda. So Python lambda means whichever I tell right now, but AWS lambda means that is a different purpose. It's for a different thing. So what is this lambda? What it can help us? Say that I have defined a function like double. If I pass an argument, it will double the values. Now, if I make a call to this function, what will happen? If I say a double of say 2, I define the function and I pass 2, it will give 4. That's it. But if I give like a 3, so it will give twice of it. So any function, any value you give, it will do the twice of it, right? Now, similarly for this, I want to create one lambda. Lambda is a keyword you need to be aware of. So same like an ordinary function, here also it will take an input, say x is. So we should call like a stated. Colon means stated. If x was given, what action you need to do, that we need to write. So now it is a function. So generally it is not recommended to define a function for it to use it. But for us to better understand, I define it to some variable, assign the same value, x stated x into 2. So if I define and now ask, hey, what is the value of this dbl? It will say that, hey, dbl is a function. And if I ask the type of dbl, it will say it is a double function. And if you say like type of this double, which is the function you defined above, both are the same. So in terms of type, both are same. So both are functions only. But this, what is this you defining like this? Means it don't have a name. So here at least you have double. But did you see that here there is no name? Assigning to a different variable is different, but you didn't have it. So to understand more using it. In the third case, we are passing an argument and we are using. Means a syntax like an ordinary function only. You pass an argument, you need not use every time, right? In the same ways here also. So when you pass, you can use it. So, and if you want more complication, I can say something like this. So if I want to combination of both lambdas and this thing, you see what I'm doing for a function, I am instead of returning the message you passed, I am saying lambda x stated so and so plus name. This is one of the interview question. So in fact, if I make a say like a birthday wish, say like happy birthday. So will it return me a string or will it return a lambda again? It will in fact return a function. Say a function is returning a function. For the first time you're seeing, right? So that function, if you want to get the result, you need to assign to something. And if I ask print, it says the same. Means this function further will take another input and it will work. So like I'm passing like this. So greet of Shushmita means as it is a function, this function will call. It is not that difficult for you to remember. So this is returning further function. For this function, if you pass an input, it will take. So message is like the message birthday and the name is what you passed secondary to it. So in fact, to conclude what I had done in one line, so whenever you're making a call, so for that you need to pass one more argument. Say same like Sushmita you passed, so you can pass the same person name. If I pass, it will work. So a function can return another function. So that's how the usage. So I will go to that. That concept is called as decorators. I will tell you afterwards more. But before going to there, so I will conclude a very small thing called as higher order functions. Higher order functions. What are these functions? See, higher order functions were the functions which were designed to work on another functions. Means till now you define different functions. All these functions have some usage. But these higher order functions, they don't do anything on their own, but they will help others to work. Earlier in Python 2, there used to be these functions directly. But this reduce, they moved to functools in Python 3. In Python 3, you don't see reduce directly. It is part of functools if you want to use. So these three are like ordinary functions. We already used, filter and zip already used, right? But I will make use of the others also for you to understand. So first, let me loop on some variables and get something. Say for number in so and so, say if I want to get the number, I can print all the numbers. So rather than printing, what I can do? So best strategy is like I can pass all the values to some variable. So for that I can say odd numbers dot append of so number. If I do after the work, I can ask what are the numbers. Then I can use it, right? If you are print only that mine, so after that we cannot use. Maybe instead of putting all the values, maybe if I say like if number percentile 2 is equal to 0, means what? I want to get odd numbers or even numbers? Even numbers. So odd numbers. Odd numbers means not equal to 0, right? Not equal to 0 means indirectly the same, directly. If you do like this also the same thing. If I do based upon these conditions, I get it. Now I looping over some numbers, I am checking the condition, and if the condition is correct, I am giving the result. So if you want to get the same result in another way, this is a traditional, right? Traditional way. If you want the same thing in another way, using the comprehensions, what we can do? I told, I can take the for loop as it is. And with after the for loop, if you have any conditions or sub or for loop, you can write. And finally, what you are adding, so that value you need to write in the starting. Ultimately, if you want to store the result in a list, this is a list comprehension. You can assign this result to some variable and you can see the value. So both will give the same result. So in not only this, there is alternative way where you can use using apply function. Means I will write a function where it will check for the function which is even or odd. For even or odd, it's a very simple thing. Number percentile 2. Just imagine if you want to check for whether it is a prime number or not, or composite number, or like some other things, it will be complex logic, right? In those cases, you cannot write directly like this, so it would be awkward. So in that case, it's better to use a functions. So in using functions, what we can do? So whatever the logic we have done directly, the same thing we can use. Means instead of writing this condition, so I can repeat the same thing with this function. So instead of you checking the result here, the same logic I push it to a function, such that tomorrow if you someone want to check, all of them they can reuse, right? Functions, reusability. Now you see, every time the function, if it is resulting in true only, it will come inside. So you wrote a logic like that. Now, so based upon this logic, they come up with one more thing, where same like applying functions only, but they told something else, that you can use a built-in function called as map. And what are the function that you have? Is odd, that function you take. So in a partial functions, you take function and one argument, right? But for a function, if you want to do for different values, so what are the values you have? You pass like that. So, but Lambda is like a optimized object. If you want to get the values, you need to convert to a list. Maybe I am converting to a list and assigning to some values. Now you see, I did a is odd and I'm getting the results. Now, did you see I'm getting true, false, true, false, true, false? Means whatever the function you give, for each of the value it will apply and give you the result. So like, so what it is happening, range is giving you values of 0 through 9, right? If you do directly like this or indirectly, it will do the same job. So means, so if I say 0, 1, 2, 3, 4, 5, 6, 6, 7, 8, that's it, right? Till 9 means. For each of the value, it will apply to that function and give you the result. But sir, I don't want. So every time what you are doing, you getting the result as if it is true or false, or only if it is true you want to get the value? So only if it is true you want to get the value, right? In that case, you can do a slight change. Means instead of map is a function. If you give a function and some values, it will apply that function on each of the things. Now another thing they created called as filter. If I apply, whomever the result is true, only those values you are getting. Now don't you think this is also a better way? Now the same thing you can do with the lambdas also in one line. Means lambda means again the function, right? So instead of defining a function outside and doing, so in a lambda, you define the lambda here itself and you write a condition, that's it. So based upon the condition, if you want to apply to all values, map will apply. And based upon the results, if it is true only if you want to get, then filter will get. Now, did you see? The same problem I solved in different ways. Now, can you take an assignment? So similarly, you implement using all the four methods using comprehension, using the for this one, what is say, prime numbers. If I ask this to be implemented for prime numbers, so give a try. So the logic is very simple. You can do. So first you need to define a function for telling whether something is prime number or not. You just Google what is a prime number. Prime number means any number which is if it is not divisible by any other number apart from itself and 1, right? So prime numbers start from 2 onwards. You can give a try. So like this it works. Next, so not only this, you know the concept of zip already. When you are going for dictionaries itself, I told, if you have two iterables, if you want to combine them, you get a zip. So if you assign that result to something else and if you see result, you can see that. If there are asymmetric values, whichever is the smallest, you will get that. And I told that, so asymmetric values will be ignored. That also I told you, right? Asymmetric values will be ignored. So that's what you should be aware of. And also, this list of tuples is only needed whenever you want to create a dictionary. If you want to create a dictionary, if you pass this list of tuples only, you get it. So to consolidate that, if I pass these groups in a reverse order, Whichever is coming first will be the key, whichever is going next will be the value. And this zip is not just designed for 2 values. I can even design 3 values also, and I can ask the zip. If I ask, if you see in this case, so what I'm doing, a zip of 3 values. If I ignore the, because why I need to convert to list? Just for seeing. But in general, don't convert to list. It's not a good practice. But if I see right now, did you see? So when I have 3 values, whichever is the minimum, it will go like that. So for the minimum value, it will do. Just to show you in a better context, instead of those variables, I'm writing directly. In zip, I'm taking 3 things. I told you can take list, tuple, set, and dictionary, anything, any iterable. Even a string also we can take, it's an iterable. But if you take a set, you don't know which one it is matching. That's why you should be careful. But if you take any iterables, one can be list, one can be tuple, anything. So the values will be matched based upon the position. But if you see which are is minimum, it will take those many number of values only. So as like ones are also like a pair, you got ones, and twos like a pair, you got the twos. Means all the zeroth values, all the first values, all the second values, like that you get it. Similarly, if you want, this is one of the interview question which was asked. The question is that how to make map to work like a zip. Generally, you have zip means if you pass 2 and 3 values, you get the result like that. But using map also, if you want like this, pairs. Generally, in map, we need to pass. If I take 2 values, I want a pair of values, right? X comma Y. So just to think, imagine if you are given 2 numbers, you need to do like this. And you pass the values. If I was passed like 2 things, this map doesn't mean that it will take only one. It can take 2 arguments also. For map, now if you and observe carefully, it is taking like first argument is your function lambda, and the second and third arguments are like this values you passed. Now if you seek the output, you generally don't get the value because it is by default converting to list only. We can better understand list or tuple or whatever maybe. So maybe like I am converting to a list, so I want to better showcase. Now we see the output, you will understand. So did you see, if you are given 2 values which it is taking like a pair, even if you have like asymmetric values, it is ignoring, right? So this is what happens. Say like you can take multiple examples. Say if you are given some values, you want to get only the positive values. If you want to get only the positive values, what is the solution? Either using a functions also we can implement, either using lambdas also you can implement. Using functions, how we can implement? I can write a function. If the number is greater than or equal to 0, true, else it is false. So this is what I want to do. Now, if I pass and the zip and filter to it, it will work perfectly. If I have a data, I can do directly, right? So we need to do like a list and a map just to get the outputs. So if I do like function and I'm applying, I get the answer. And this function, assume that it is used only once. Then what is the point of defining it? If it is used only once, then I can do with the lambda also. Lambda x stated, x or y or anything you can give. Maybe like number you want to say, number stated. So you can write the same logic. So number so and so. If it is so and so, it is true, else false. So true if so and so, like that. And the same thing you can repeat here also. So instead of the function, you can do. You see, both will give exactly the same thing, but the things are different, right? So let me give one last practical example before closing it. So Caesar ciphers. Caesar cipher, I already told the concept of Caesar cipher. Caesar cipher means in cryptography, we can have this concept where whenever you have a value, if you want to replace it with the next third character, so generally go for Caesar cipher concept. If you want to implement that, so I can go again. So let me go with a very simple example. generally print of list of, generally print and list, these are like noise for you to understand. I'm telling, right? So print is just for printing, list is for converting, because map by default will not give the values directly. If you want, you need to better give. So if I do ch stated, ch means it is taking each of the character and giving. So map is like giving the values. In the same fashion, if I do like one extra smart point, instead of getting what are the value, which is a character, if I'm doing ORD of that character, means what? I will get the number of it. So instead of getting the ORD of it, so what are the number? I can do +3. See, +3 I'm doing. So I get the next third character. So if I get the next third character, which is a number, if you get a number, if you want to convert and get the character out of it, if I give a number, so I can do a CHR. If I do a CHR for that, again I get a character, right? So for this +3, if I do like CHR, now did you see? I get one more character. Now, if I want to join all the characters, so what is the best solution? Delimiter.join. If I do delimiter.join, you got it? Means the word Python was converted to this one using the Caesar cipher. So not only that, I can use this concept, which is the final made for anything. So today, so is plan for ambush at the river end. So it means like this only Caesar used to send the messages, secret messages for military purpose. So this was converted like this. So I created like this, which is a super idea. So like that we can do. So not only this, so one of the other thing that is happened is like we can make use of this for a different purposes. If I was given some lambda, say here lambda x stated x into 2, so which we already know is double. If you are given any number, you need to double to 2. So for the numbers which are given, it will multiply to 2, right? This is what is known. But what if you pass 2 arguments to it? So till now you know that lambda can take like one or more iterables. But during the function definition also, if you pass 2 arguments, so what will happen? So then it will throw in error. So what is the error here is that, hey, missing one of the argument value. Means if you are passing 2 arguments to your function, you need to pass 2 values. Means, observe carefully, for a lambda, so means within the map, if you are taking lambda or an ordinary function, if it is taking more than one argument, say 2 arguments, you need to pass 2 iterables. It doesn't mean that both are strings or both are list or anything. Any iterables you need to pass as per your design. Say like if I am passing like 2 arguments and I am passing 2 strings. Of course, the logic works, right? Only 2 strings can be added. So what are these we have? I can pass like that. Whereas if I have 3 arguments, so if I have 3 arguments, whether I used it or secondary, but I need to pass 3 arguments. So this is one iterable, this is one iterable, this is one iterable. And only iterables we need to pass. And similarly, so when you want to use them, so maybe like I give a try, so to use them, say whichever the third value I got, z, I want to use. But you see, both are strings, they will add. But this is an integer, right? It will not add. So then what is the solution? So I can convert this to a string. So then I can add, right? So, it is not readable, that I can understand. So whenever you go for lambdas, these are not that readable, like in ordinary functions. But with expertise, you will come to here, to this stage. Whereas there is one more thing called as a reduce. So reduce is very interesting. So reduce is basically, I don't know why, but so these Python people don't want people to use this. That's why they changed it. Basically, it will take a single iterable only. So and return single value. This is the most important point. Till now you have seen map, zip, filter. These will take a list and give a list. So each value they will apply. But what is this reduce? This is very interesting. Basically, reduce if you directly use, it will throw an error because it doesn't work. If I ask, say, reduce, if I ask, it will throw an error because we don't have. So people generally do like this. From functools, import, reduce. Like this selective import they do, and they use it. Because every time they can't do functools.reduce, functools.reduce. So after that they use it. This reduce, even if I do directly without any argument, it will say that please expect two arguments. It will take only two arguments, a function and one iterable. That's it. And did you see, remember, when you did like this, when two arguments in an ordinary function, hope you remember you passed like two functions, two iterables, right? So 5, 6, 7, 8, something. So when you are working with a map, hope you remember you did like this. So you got a result. So if I do like a list of it, we can see the result. Whereas the same thing if you do for a filter also we have seen. Filter means what? So for which are the values, it is giving like result, we get it. I think something happened. So same like map, if you go with the filter, you can notice that. So it is saying like filter will work like Lambda map itself. Filter expects two arguments, got like three arguments. So the reason for it is very simple. Basically, filter will filter based upon a values. That's the reason filter is not suitable in this example. Similarly, if I go with one last thing called as a reduce. Reduce, if you see the output, we need not have reduce directly. So reduce we can get from the functools, functools.import reduce. And we need not convert this to a list again because by default reduce will give a single value. So it is easy. And one more thing is that if I use directly also, reduce will take only one iterable. It will take only two arguments. One is your function and an iterable. So it will not take more than one. Means we should remove the second also. So now it will work. So what it actually does is that it will go to each of these values and do the operation. First, it will do the operation between these two. So x comma y will be like this. So next, like so x comma y equal to like this. Then the result will be like, so again x comma y is equal to, it will add these two. So x will become like 3 and y will become like 4. So, so 3 and a 3. And like in the next iteration, it will do like, 3 comma 3 is like 6. And it will take the fourth argument. So means cumulatively it will work on the same objects. So the simple example for you to understand is, if I take the example of say factorials, means like if I take this example of what I has given, in fact what it is doing, first adding these two, then result like that. So whatever happens, it is doing like that. So technically reduce will give only one iterable. So it will take only one iterable and give a single result. In the same fashion, if I go for like passing the values and multiplying them, it is same like factorial value, right? So 1 into 2 into 3 into 4. So cumulatively we add to the values. So if you do want to do the same thing with a range also, you can do. But range, why you are passing 1? Because by default, if it starts with 0, then everything multiplied by 0 means 0. So like this it will work. Reduce will take all the values and it will create a single result. You pass anything, it will take like that. So the simple examples we can take, if you take one example like this, see here, if I take two a colon b, stated a plus b, So each value you want to add. You cannot take 3 arguments or you cannot take 2 arguments for this lambda. So only 2 arguments so that it can go through each of them. If you give 1 argument, it cannot do anything. And one of the problem or point here you can understand is there is one more module called as operator. Operator. So this is like a built-in module. If I do like a DAR of this operator, so what it is, the most common operations that we are doing. So they created like a function for that. So like for addition, multiplication, modulo, for all these things they have. Means we can use, say in this example, we are commonly using this addition, right? If you are given two things, you want to add them. For doing the same thing, instead of these lambda functions, they have pre-baked, ready-made. So we can use operator.add. So it will do the addition of all the things. And similarly, if you are given two values and if you want to multiply them, generally in lambdas, what you take? You take two variables and you multiply them. In the same fashion, if you want to implement with operator module, so we can do operator.mul. So operator.mul, operator.add, operator.negative. So like this we can use for every operation. So like that we can work. In the same fashion, if you are given like two strings or anything, we can use a string addition operations. So if you are like given two strings, so I can do like a string.concat or like this. But not every time the operator.add can be better helpful. If you see in this case, I have my string is having a tuple of strings. If I do with a operator.add, I'm getting all of them like this because it's just to add. But if you want to do modifications like when adding, I want to write some space, operator.add cannot do. We need to have our own customization. Of course, delimiter.join is another way, but I'm just giving a small example. These can be helpful for certain purposes, but not for all the purposes. And one more example. So if you want, say, get the cumulative result, then intermediate values if you want. So means if you add two values and you get the result. So final result you get, or operator.add also you get the same result. But intermediate values if you want at any point, there is one more module called as iter tools. So if we do iter tools.list of so and so, so during the addition, it will give the intermediate sum. Means till then what is the sum? Like that it will give. So like that, so we need to work. In the same fashion, you know the different kinds of higher order functions which I told. So the last thing that I want to touch base is on the recursions. If you want to know more about the recursions, so you need to understand that basically recursions work like this. Whenever a function is there, so if you are returning the same function in return, that is called as a recursion. The pseudo logic for any recursion function is simply like this, that whenever you have a function, if you observe the pseudocode, it's very easy. A function name is there, it is taking some parameters, and you are returning again the same function with parameters. Means the function definition is the same as the return also. So this kind of things are called as recursion functions. So if you want to know more about these recursions, so maybe like we can use this. So for that, there is one good online tool for this visualization. So it's called as like so virtualization tool. So rather than I explaining directly, let's open that to better visualize it. So they have created some built-in things so to beautifully explain you. So what is this recursions? How they can help? I can also create my own function and I can do say define hello. I'm defining. So if I do like a ordinary function, print hello world, I did. So this is a hello function. So what I can do, hello function I am doing. This is a definition, I'm making a call. If I visualize, it's not a recursion, it's just an ordinary function. If I do like every step also, it would be the same. So there is nothing, it's a simple output. But if you make a return to this, so till now, if you make a return, so you make a return of something, so maybe like hello or something, you make a call. So that also we know which are is returning. But what if you are returning something else? Means instead of a ordinary return, if the return is again a hello function. Now in this case, you will understand. If I execute, you will notice that it's a recursion function. The same function is calling the same function again. So what is the problem like this, sir? If for that, if you understand, let me go with the functions with a Python script, maybe like d recursions.py. If I write a small program, so define hello, and I'm printing hello world, and I am returning hello again. If I go for the terminal for the same new terminal, I can navigate to the directory or use it the same. If I navigate to the directory, I can directly ask, right, Python d so info. If you execute, nothing is happening because you made a call. So means you defined a function but not make a call. So the moment you made a call, if you see now what happens, it is executing like crazy, the same call multiple times. If you go for the language like C or C++, it will go infinite amount of time. Whereas Python has a safety net. And did you see after executing for n number of times, it is saying what is the error? So recursion error, maximum recursion depth executed while executing this call. So now did you understand something? Means it will not go infinite times, it will stop somewhere. That we understood. But how many times it is executing, we don't know. So will it be the same every time or will it be different for every time? So, okay. So to understand before that, let's go traditionally how to build a solution. So if you want to get, let's say example, if you want to sum some values, a list of values you have, you want to add them. So convention method, for any problem, there are two solutions. One is iterative approach, other one is recursive approach. In an iterative approach, if you are given a list of values, then how do you add all the values? Of course, we have a sum built-in function. Assume we don't have. We take a total sum and like we loop over the each of the value. So, and during the process, whenever you got each of the value, you try to add the value to the total result. You add the value to the total result and you return the total. You return the total. So this is how you solve this problem. And if you make a call to this also, it will work like this. Now, if I execute again, so if I clear the screen, if I execute again, it is not executing anymore because I didn't make a call, ignored it. And now if I make a call, I'm getting the total sum. This is fine. Now the same problem can also implemented using recursions. Means recursion is not mandatory. This is one of the approach. But so in recursions, whenever you're defining, I gave you one thing, which I didn't discuss much, but I gave you one thing. What I told is that whenever you are defining any recursions, you need to follow three rules. The three rules, laws of recursions I told. Recursion algorithm must have a base case, means finally one case where you want to stop. So that we need to have. In other case, we need to do the job as it is. Means if I do like a return, again sum of the recursions of the list of numbers, assume. And every time within the function, if I am doing like this, so print of f of, so values like this. So, and if you make a call to the same thing, say how I made a call to this in the same fashion using recursions, right? Underscore recursions, I don't. I expect the same answer like 616 if I execute. What is happening? Every time the list is same, it is executing for some n number of times till we don't know the number, and finally you got max or recursion happened. So what is the problem here is means, so every time the number of value should reduce. So every time if you pass the same thing, it makes no sense. So what is the best solution is, in the recursion, you need to take, say, 0th value, and I want to add to the 0th value the remaining result. So like that, if you want to do, I can say like this. From 1 onwards, I want to pass to the remaining. Now you see, if I execute like this, you see what happened? This time, instead of the recursion error, each time what I am getting? One value, it is reducing. From second value, third value, fourth value, like this. At one point, the list became empty, right? So then it showed an error that index out of range. Because when list is empty, I cannot get the 0th value. Now, don't you understand that slowly when you reduced, when the list became empty, there is nothing to do. So we can write a logic. That is what the base case, when you want to stop. If list is equal to empty, then you want to stop, right? Then you want to stop means you can say return. If I did a return, you see now another issue comes. If I clear the screen and you do, now what is the error? This is a different error, type error. Hey, I cannot add an integer and a none type. Why you got a none? The default return is none. If you don't return anything, it's a none. If you return also, the same thing happens. But instead of returning none, if you return a 0, because as you want to make a sum, the result should be 0. 0 makes no difference. If I execute right now did you see what happened? Whenever the values become 1, just ignore. In other cases, every time get the 0th value and add. Now, if this function, if you are passing to this visualizer, it can better help us. So maybe like this call, we need to pass to it, right? Yeah. There are like different visualizers. So this is one thing. So I will show you one more visualizer also. It's a better visualizers. You see now. So every time I'm printing the value and I'm asking, you see what happened? Whenever I have the total values, I passed that. I took the first value, which is a 12 outside, and remaining values I passed. So I took the 23 outside and the remaining values I passed. I took the 34 outside, remaining values I passed. I took that 5 so and so outside and 1 I passed. Finally, and when it is empty, I returned a 0. So for 0, what is this return value, which is a 1? 0 plus 1 will be added. For that, this value will be added. Like that, for every recursion, reverse way, it will add all the values and you get it. So now, did you understand? So if you want to further visualize it, there is something called as Python tutor. So there is something called as Python tutor. If you go to that, there is a better visualizer. This is like for anything. For Python, JavaScript, C, C++, Java, they created for multiple things. If I go for the Python and if I give, and if I make a call same like this, I took some values and I need to make a call inside itself. And if I click on the visualizer, unsupported syntax f strings means still Python 3.6 only. Yeah, they are not updated. Okay, ignore these values. So it is saying f string assignments are not supported. So f string, okay, if I execute right now, you see now it's working. Okay, close it. Fine. So you see what happened each time? Each time how the logic is executing, see here. When the movement it is creating, it is going inside. If the value is equal to empty, no, it is going inside. It is trying to print the value and it is going further. Did you see it is creating one more frame? So further, it will go open, create another thing, it will go inside, further create, go inside, further create, go inside, further create, go inside. So like that, for every frame, it is going further inside and giving the value. Finally, the all results, it will sum up and give you the total result. So this is how recursions will work. So let me give like one more example. Okay, the same recursion you implemented, right? So using the 0th value and we added. So that is what I just showed. Using recursions, how you have implemented. Every time you are taking the 0th value and you are appending to it. 0th value you are appending to it. So finally when become wrong, you are doing it. So it doesn't mean that every time we need to do like this only. So we can do the logic slightly other way also. Means, so you have taken implementation like this. What if you want to say like, you want to give all the values. So till the last value means till -1, and the final value, the last value you want to take of -1 you want to take. The same thing in a reverse way, that's it. So it will also execute. Means it's up to you how you have implemented. So either like this also you can implement, or in this way also you can implement. If I pass this example now, means what I am doing, instead of taking the 0th value and adding, I am taking all the values and last value I am taking to add. So if I implement, the same logic works in visualization, but here the way it approaches is slightly different. You see, the same thing. Instead of getting the 0th value, it will pass these all values to the next one. So every time this will pass. So including the last value, ignore the last value, ignore the last value. Means it's up to us how you implement this logic. So if I go for like one more example, so for like string reversal. So D2 string reversal. It will take a moment more. So for you to better understand, if you want to make a string reversal, so it's a good idea. How, let's say you have a string. So you have Python. If you want to do the reverse, what you do? You take the first character and place in the last. Again take the first character, place in the last. Again take the first character, place in the last. So did you see like that you moved? Either first character you can place in the last, or last character you can place in the first. Now we see how I implement the string reversal. If I want to reverse, so what I do, if I want to do with recursions, I need to repeat the same thing. If I do a return of the same thing, so and if I make a call, it will throw an error. That is for sure print of string reversal of, if I do like Python. So Python D, I think here I marked it as instead of D2 something around. Yeah. So string reversal. So D2. Okay. You see now, again maximum recursion depth exceeded. So each time if you print the word, so print of word, you can see that. So the word will be every time Python, and we need to reduce. So what I'm trying to say, every time get the 0th value and add to the last. So what is the 0th value in the word? 0th value I'm adding to the last. And so we need to take till the last value. So means like from first value onwards, you want to add to the last. If I do like this now, you see what will happen. So every time the same thing. So means after some time the value is empty. So that's why it is repeating those many number of times. So whenever it is empty, so if so length of word is equal to 0, then what you want to do return. Say like you want to do return none, same like in the previous. It will throw an error that hey, I cannot add a none type and a so and so. Last time you returned a 0. If I do a return all 0 also, it will throw an error because a 0 cannot be added to a string. Then what should we do? We should return an empty string. If you return an empty string, so it will stop the movement. So don't you think that the reverse of Python you got now? So whatever the Python, that reverse that you want to do, you got it, the final value. So each time it will take the reverse value, reverse value, reverse value, like that, something it's showing. In the same fashion, we can also do the same reverse of a string, the other side. Means instead of taking the same word, maybe like I will do the other side. Means I will take the last character first and I do it. So in this way also I can implement taking the last character first and implementing. Means it is up to us like how you want to implement. The final result is like how it works and if you can use it. In both the cases, the result will be the same. So this is all recursion. Maybe like there are good examples for recursions, like a factorial. So if I go for like a factorial example, that is another good thing. So if I go for that, yeah, this is a good example. Generally in a Jupyter notebook, don't do the infinite recursions. Then it will be very difficult. Again, we need to restart the kernel. So how do you implement a recursions here? If say I want to implement factorial. Factorial means what? If you given a number, till 1 you want to get all the values. So means what? Return. So what are the number you give into factorial of, so number minus 1 every time you do. At one point the value will become 1. So then if number is equal to 1, then you can say return 1. So in this case, you see, if I do a factorial, say factorial of some 9 or factorial of something, I can see the result. Print of, say f of, say factorial of say 9 is equal to. Now you see in this case, each time it will go to each other value and give the next values. Maybe like intermediate values, if you want to see, you can write like /t. So number is equal to. Number is equal to. If I do, if you see, each of the number, first 9, next 8, so and so it's coming, right? So that is how I implemented. So you factorials. And also things like reduce can also be used for implementing factorial. So, but like I'm telling, a problem can be implemented different ways. I'm just helping you to understand. So there are different ways of implementing. So you can take the choice whichever you want. And similarly, so Fibonacci series is one of the most important asked interview questions. So especially whenever you are working. So if you go for the Fibonacci series, which is a problem, Fibonacci series means the first two values will be 0 and 1, and all the subsequent values will be addition of previous two values. All the subsequent values will be addition of previous two values. Then how to use it? This problem can also be solved in two ways. Using recursions also we can solve, using iterations also we can solve. For that matter, any problem can be solved using iterations or iterations. But it is up to you whether to choose something or the other. If I want to implement using the recursions first, so I define recursions. I know that the first two values are 0 and 1. Means for any value, I want to take previous two values. Means Fibonacci of n minus 1 plus Fibonacci of n minus 2. For every value, it is the previous two. But the first two values are 0 and 1, right? So I can say like, what are the values? It will come down. If number is equal to 0, then you can say like, return 0. We should not give a negative. Okay, that is how this Fibonacci works. So if so number is equal to 1, then you return 1. In other cases, you want to do like this. Now in this case, if I ask, hey, give me the Fibonacci of 5. So you see, Fibonacci of 5 means it will go and implement. Why I didn't get? Because it is treating it as like a marked out. If I change to Python, it will execute. You see, you got 5. So how it actually worked in the backend? So whenever I am asking 5, it is in fact taking a 4 and 3, right? In the first case, it will go and take 4 and 3, 4 and 3. And for 4, it will further ask for 3 and 2. So for like this 2, like that, it will go recursively. If I implement this example in a visualizer, you can better see. If I say like, fib of 5. So fib of 5, you can notice the visualizer. See, for each call, 5 will go for 4 and 3. And again, 4 will go for 3 will go for like 2 and 1. And again, each one further. Similarly, here also, here also, here also. For everything, there will be 0, 1 finally, right? So that's why you made a base condition. So like that, we visualized anything. So this is what you need to be aware. But do you mean that if you want like some number of values, generally in interviews, they can ask, give me the fifth value or all the values till 5. So if you assume that you are using this function, If you want to get all the 5 values, I can do like this. Each value I can pass. So I can execute. What is the 0th value, first value, like that you got it? Or similarly, if you want to get all the 5 values at one shot, using a recursive approach also I can go. I just took like the first 2 values as 0, 1, 1, and within the for loop, I am not using the index value. That's why I'm doing an underscore. And each time I'm assigning. So the first 2 values are like, see, this is the most important point. This is called as tuple unpacking, right? Hope you remember. So tuple unpacking, or like just simple unpacking. And I'm asking. So now you see, each time when I'm appending, I'm getting the first 5 values. Mark my words, this is the most important thing you need to be aware. So, and also in recursions, whenever you're working, you need to understand that Python doesn't have like tail call optimization, which you aren't aware, but still I'm telling. So Python don't have like a tail call optimization to handle the recursion functions. But there is something called as maximum recursion depth whenever you're going for any functions. So what is that logic of maximum things and till what max it goes? To understand that, so let me go for a small, maybe like E infinite recursions dot py. So if I go for a small function, you can notice that. So I have a function which I'm displaying. If I say like a display of say Python, so we can complete in 2 minutes. If I go for this, if I go for this function, say Python is so and so, if I execute, did you see the same function is repeating multiple times? And you got like maximum recursion depth executed when you're working. So till now we are understanding that whenever you didn't give the conditions properly, it will go to infinite recursions, but we don't know what is that depth to which it will go. This depth will be slightly different for the interactive mode and script mode. So if you want to know, there is something called a sys module. Using sys module, you can do sys.get recursion depth. If you ask Python is so and so, did you see what is the sys.get recursion limit? Let me do the same thing in a script mode. So script mode we did right now. In a interactive mode, means like in the Jupyter notebook, I am trying. If I implement the same, did you see in this, you get a number which is like 3000. Means in interactive modes, they will give a bigger number limit. Whereas in a script mode, they will give a lesser number. So why this is different? So we need to be aware of. So by default in script mode, it is so and so. In interactive mode, it is the other side, 3000. So can I increase this limit? Yes, of course. If you want to increase the limit, there is one more operator called as set recursion limit of 1500. After setting, if you ask, hey, what is the limit? It says the limit is 1500. So once you set, this setting value will be there temporarily only for this function. Subsequently will be there. So, okay. And the next thing is like how many times it is looping that I want to understand. So it will, I'm saying that it will loop for this maximum recursion limit times only. To clearly understand that problem, let me create one function. Within the function, I'm defining plus equal to. Every time I'm increasing the loop count and I'm asking what is the times it is executing. Say I am taking some variable and I'm asking, say I am saying that initially the number of recursions equal to 0 I'm passing and I'm executing. Now we see, now you will understand. It is saying that it is going till 1496 and it is saying stopping. Because you have increased this limit. Let me comment these 2 lines. So the default limit is, in a script mode, it is 1000 only. If I execute route now again, did you see it is saying 996 and so and so? Means if I do 1500 also, 4 frames are left. If I do 900 also, 1000 also, 4 frames are left. means for the basic program to execute, also it needs some memory, right? So just imagine like on a table, you are placing all the books open. In a recursion means what? You open one book. To understand more, you open another book. To understand another book. But if a table has like a small size, you cannot open more than 10 books or 15 books, right? The same thing. These frames are also open. For every frame also, it will take some memory. So that's the reason recursions will be memory intensive. So until unless you know the reason why you are using, and if you are very sure, you go. So else people don't go. But it's a very straightforward and fast approach. So, but now you understood what is the total number of executions, when it will be stopping. Basically, sometimes during our executions, we need to go deep inside. Sometimes maybe this number we need to increase. So due to our problem. So in that case, we can make use of this limit to increase it. So I have used it in multiple cases like that. And there is one more example for you to be aware. So recursion doesn't mean that there can be a straight recursion. Sometimes there can be a indirect recursion or mutual recursion. Observe that I define two variables and I'm making. You see, the first function is returning a call to second function, and the second function is making a call to the first function. Now, in this case, observe, though you have the recursion limit of so and so, if you execute, see what will happen. It is executing for n number of times and it is giving the result. And if you observe, so what it is doing, you see what happens. First function is returning second function is returning first function, like that. So totally, 1,000 times it has. Each one will execute for some times and you will get it. So, and if you want to handle these recursion limits, so there is another way. So here, recursion error is also one kind of exception. If you want, you can handle that also. So when you handle that, did you observe carefully? So totally, each one is taking 495, 494. Because totally it has 1,000, right? So the maximum limit is 1,000 only. So that's why it is executing like that. Hope it's clear for you. So this is all about the recursions. So, and we can stop here. We have like inner functions next. So inner functions, closures, and like closures and decorators. Inner functions. So what are these inner functions? How they can help? Typically, we have functions. Say like some function, say my func. So we have some logic, maybe pass. And similarly, like another func. So I can say like a pass. So if I have defined two functions, when I make a call, individual, I need to make a call. Maybe like, so I will, if you want to just make a like empty functions, I can define like this. Or if I want to make something meaningful, I can write like print. So in my func. In the same fashion here in another func. So when you define them, we need to make a call. So my func, if I make, you will make a call to only one function. Similarly, if you make a call to other func, so individually the other function will happen. But you see, what if you have defined the other function within the first function? So now it will be in such a way that you can call the first function. So automatically it will call my func. But if you call the other function, so maybe like, I define it as other function too, because I defined there, right? So other function too. I define like other function too. I want to execute this other function too. When I execute, it says that it's a not defined. So if I make it in a literal sense of what we have worked with the outer and inner functions concept, so there the concept is very simple. So you define like an outer function, any function name you define, and you have an inner function. Say define inner function. So here we can say like in outer function. And similarly, you come here, we can say like print in inner function. If you make a call to this from outside, say outer if I make, so the outer function can be called. Then how to call this inner function? If I call, because inner function is defined within that outer function, you cannot directly call. That is what I showed there also. Then what is the solution? First of all, in which case we need to go like this, in which case we need to go the other way. So very simple. If I go for the practical usage purpose, before even going, if you want to make a call to this inner function, we need to call here. See, I cannot make a function call before the definition. You see, though definition and function are there, I cannot make a call like this. It will throw an error because Python execution happens from top to bottom, left to right. So any function, if you want to make a call, first it should be defined, then only we should make a call. So first it should be defined, then only we make a call. So when you are making a call also, you should be very careful. If you here do perfectly, it will work. But if you place the same indentation one level below, then it will never work because you are going within it. So we should make a call in such a way that it can do. So in this case, it will not execute. Then the only solution that we have is we should make a call here. If you go for like some practical example, say only if a number is a even number, I want to get the twice of it. So if that is a logic, I want to check, define is even. Okay, so is even, I defined a number. Say like I am taking a number. So print, say like in is even function, just to be aware that we have inside. If you make a call like is even, say like some 10, it will execute and says that it is inside. Now I want to get the twice of it. Define double. Double is a function which I define. If I was given x, what are the x may be? Return 2 into x. Now if I define it, it will not execute anything. Now the point is like if number percentile 2 is equal to 0, means it is even, right? If it is even, then you make a double, return, so double of this number. So you write some condition, it's up to you. Maybe like you can have a better logic. Say like you are doing some confidential things. If someone is authorized only, then you should have a DB connection or some other accesses. So in that cases, you can give for these inner functions. These are the practical usages. For outside people, you generally don't give. Only for the inside people, they can manage it. So this is most important. Now, in this process, you need to learn one interesting point. What are the changes you make? So it will be generally reflected at the outside, right? Now here, there is another built-in function, another keyword, sorry, called as non-local. Non-local and the inner functions. What is this concept? How it can help? Till now, we know the concept of global and local. Now let me introduce you this new concept. Let's say I defined a name is equal to some like a global level. Say I defined a name is equal to global level. So it's easy for us to even understand and recognize. So after defining, I defined a outer function. Say define outer of. Within the function, I say that, hey, name is equal to outer level function. And within the function, I define inner. Inner is another function I define. And within that, I say that, hey, it is a inner level function, I say. So how do you make a call? I told after defining only, you need to make a call. If every time you want to make or based upon a condition, you decide. So now I need to get that entire things to be done. So outer function, I make a call. Till now, you know that. So from outer, when you call, this will execute. And in this function, I didn't make a print, so nothing is printing. Say like I want to print these values. So maybe like the inner level I want to print. And at the outer level also I want to print. Outer level means here also I can print or here also I can print. So it is like a outer level. This is like a inner level. So or like outside also I want to print. Outside means the global scope. This is global scope, which is outside this function. So this is like a local scope. But for inner function, this is our global outside scope. Global, right? Everything is global. Within that, that is local. So every function has its own local and global, right? So now in this case, if you see at the inner function, within the inner function, if I ask, hey, it says inner function is so and so, means what are the name you defined within it, that is the scope it has. So at the outer scope, if you ask, what are is the outer level, so you got that. But outside, if you ask, what are is the global level, you get it. So this is what we learned till now. The same thing I am defining now. So one level up I do. I take the same example and I will do one more use case. In this use case, I am marking the inner value as a global. So if I define the inner value as a global, so now also it will happen, right? So till now they are trying to use the global values, and if the locally if you define it is using. Now the point global means what? What are the local changes will reflect outside. Outside means this is a global or this is a global. So that's let's see. If you see in this example, did you understand? You define this as a global. So what are these changes were reflected to the outside. Inner also you have the same thing. But did you see at the outer level, you got the outer function only? Means what are the changes you did deep within this inner function were not reflected to this outer scope, but directly to this global scope. So directly to this global scope. So that's why see here. So outside you are seeing there's inner function, but middle you are not seeing that. Means in the outer function within that you are not seeing. Means global means only at the outside it is making an effect. This is one thing. So means which are affected, which are not affected. If I can make a note, so in one shot I can get it. So in one shot I can get a note. So when you change this one, so this is not affected, but this one is affected. So then like what will happen, sir? What can I make the other things? Means this low global variable also is global. Now we see here. As this was made as a global, so here also I will make it as a global. Global name. Means what are the changes you make here also you want to reflect outside. Here also you want to reflect outside. When both are reflecting, which one will effect will be there? So, deep within it, so will be affected. So this is also affected. This is also affected. Everything is affected, right? So what are the changes you make that you want to make to the global level? This change also to the global level only. But at the same time, they created one more concept. So whenever you want the changes to be gone only one level down, not for all of them, so then we need to go for another concept where you don't define everything as global. That's a very worst way. If you want your changes to go one level above only, not to the global level, you need to define as non-local. This is another keyword in the list of keyword function as keywords you have. So the moment you define something like this, then observe carefully. So the inner function you changed, and which is getting affected one level above. So non-local will affect one level above only. So one level above means, so this outer function. Did you see that this was affected? But the global level was not affected. So now the conclusions are like this. So whatever I told is like this. Whenever you want to make changes, if you have like a single function and to the global level, if you want to do, you can mark it as global. But whenever you are in multiple, so inner functions, if you want to make your changes go one level above only, then we need to go for so inner functions. Sir, why we want to make local changes to go only one level above? Maybe like, so you want to retry for something. If something was failed, you want to retry for 2 times or 3 times. So that change should be locally only. Again, when a new call is started, again it should think like, so retry should be start from 0, right? So retry count should not increase. So that is what I'm trying to say. So to repeat, one more example to give. So if I give this example, say like, so based upon these conclusions, so I am giving one more example. I am saying x equal to 0, which is at the global level, x equal to 1 at the outer level, and x is equal to so and so here. Now in these things, if I don't define like global or local, so if I just define it and if I make a call, so if I make a call to it, say how I do outer. So and after this outer, if I print like at the global scope, so inner scope, outer scope, and global scope. So if you see what happened when you change it to 2, the inner one is also only 2. So whereas this one, what are the changes you did will not reflect outside. So whatever the existing value is like 1, you get it, and way outside it is 0, you get as it is. Whereas for the same thing, if I go with one more example, so here if I define like a global, so global x, so what are the changes you do will reflect to the outside direction. You see, inner one is 2 and outside is so and so, but the middle one is not changed. What if you want the changes to be going to the in middle value, not for the global level? So then you need to define as non-local. The moment you define like non-local, the inner changes were reflected one level above, but the global is like as it is. So this is what the conclusions we note. So the conclusion is that this outer level not affected when global, affected when local, non-local. So whereas this one, so the global level, when it is affected, affected when the user has mentioned as global, so non-affected when the user has mentioned it as non-local. So this is the conclusions of non-local functions. And the next one, based upon these things, we can go for something else called as closures. So what is this concept of closures? How they can help us? There were a lot of advantages. I'm telling that, right? What is this closure and in which case we need to use? So there were a lot of advantages. In fact, closures are same like your functions, but with a slight difference. So what I do, I define one function called as outer function start, and within that I have a inner function start, and I did a return. It's a typical function, right? So when I make a call, it will execute. If I execute this function, it will work. So there is nothing. But if you want the inner function to execute, then how do you call the inner function? So in case 1, first you define that function and you make a call. So this is how we did till now. The same thing I will do here also. If I do like outer, then it will execute the inner function also. That is good. And in the second case, instead of just calling, so what if you want to return that result? You see what I'm doing in the second case? Instead of calling the inner function, the result of the inner function I am returning. Means first it will make a call to the call. So whatever the result is there of this inner function, that will be returned. Now, if I say outer function, it will just execute. But if I, instead of just executing, if I return the result value and I take that, consume it, you see now, so it will execute and give me the result also. Means from outside, we are able to call the inside function. So indirectly in both the cases. So fine. But directly we cannot call from outside the inner function, right? The inner function can't be called from outside inside inner function. So that is a standard problem. Then how to address this? So to address this, we can go for the last case. So the last case is that, okay, here you are taking the second case where you are returning the inner function result. Now slight difference I will do. Instead of returning the inner function result, I am returning the inner function. Observe, this is very, very different. So instead of returning this something, it will return this entire function. Now we observe carefully. It will say that, hey, from the main, means outside, you made a call to the outer function. This is outer function. So 2 with some relation with a inner function. This is the inner function you have. So this kind of relation you mapped, right? That mapping is called as a closure. So what is the advantage, sir, of getting this kind of mapping? So earlier, when you made a function call, you got the result and you asked the type. It said it's of type something because that is what returned. But this time you are returning the entire function. Means see what will happen. If I made a call, earlier it happened. I'm making a call and asking, did you see that result is having again a function relation? Means, so from outside till now you couldn't call the inner function. But for this result, if I make a call, did you see that the inner function is called? So in short of whatever I did, if I can conclude, so it is like this. So for the outer function, you are getting a result and I'm making a call. If I make a single call, I get the function. But if I make one more call, so I get the inner function result also. So this is kind of like something that you need to be aware of. So let me give one example, then slowly you will understand. Hope you remember earlier we did some partial functions, right? So like that, let me do one partial functions. Say partial functions we implemented using functools. Hope you remember. So whenever you want to multiply with something, you created one thing. So like that, if you want to create, say define make multiplier of um, of say n. If I pass, and within that I have defined one more function. Define multiplier of say y. I define. So return. So this n into y, or like make it as x. I will say x, and I do return like x into y. So x will come from the first value and y will come here and it will return. Now here I told closure means what? The inner function you will return, not the inner function result. So then it will become a closure. Now if I want to make a closure, so what I will do, I need to make a call. As it is taking one argument, I give 3. Now did you see it made a something? Now for us to clearly understand, so what I will do, so for the same thing, I pass like that. I take that result to some variable, say a multiplier of 3. Say I assign to some variable called as mul3. Now for this mul3, I will ask the type and the value. So if you ask the type and value, you can understand it's of type function and you got the so and so. Means mul3 became like a multiple 3. So for this multiple 3, if I pass like 4, 3 4s are 12 will happen. So the first value, whatever you gave, so will be like 3. The second value will be the second value you give, and you get the total result. So similarly, if I pass like anything like now, so it will work. So if I pass like say, so mul3 of 7, if I pass, so it will take 3 and it will give it. Say mul3 of 7, 3 7s are 12. It will execute. So maybe like if you want this result in a better way to show, I can take the same thing. Here I can represent. So print of, so whatever you give. So x equal to y is equal to, and it can do. Maybe like you give a /t, /t. It's easy for us to digest. So why multiples of 3 every time? So let me create a multiples of 4. Say I pass like 4. Say I define like a mul4. Anyhow, it's a function. So now I need to make a call. I define this function and ask, hey, mul4. It's again a function with this relation. So for this mul4, I give like mul4 of 2. 4 2s are. So first one 4. Whatever you gave the first value, that is a 4, right? The second value is so and so. Similarly, mul 4 of say 5. 4 5 is a 20. First value is 4, second value is so and so. So like that we created a use case. So let me give you one more example. Does it mean that in the every function has an inner function should be like this? Means no. Let me give you one more example. Say I have an outer function. So within that outer function, I have one function. So in this function, I have something. Let me have like one more function. So maybe like another function called as a wrapper. So in this case, I have defined a function, but I am not making a call to anything. So I just defined something. So I am not returning anything. So if I return like hello world, that is will happen. So if there are two functions, I can make one of them as a um, return. So whichever you want to make a closure, return that. Means within one function, there can be multiple inner functions. Only one of them will be a closure. You cannot have more than one closure within a function because only one thing you can return, right? So return is the last statement which will execute. If you make based upon conditions multiple, that is up to you. But finally, only one will be there. So if you do like this example, say I define number 1 and I defined one more number, say number 2, number 3, and here I will define like number 2. So like that I define 3 numbers and this result I want to return. So maybe like here I do a summation and I will do a return. So finally this wrapped value I am doing. Now if you want to know whether something is a closure or not, so there is a function actually. So for every function, I told functions are also first class objects. We can have a wrapping to understand. I can ask like, hello world function, is it a closure? Wrapper, is it a closure? In fact, you are returning wrapper, right? So that is a closure. So as I told you, so this function, if you directly execute, it will not execute because it's taking one argument. If I can take to some 10, it will take it. So it will give the result. Rather, if you want this return to be assigned to some value, I can assign to some variable. So instead of just so I can assign outer result equal to so and so. You can see it is a function again. So from outside, you can call the inside value. So during this process, did you see? So in both the cases, I forgot to say one thing. So whichever is wrapper, it is saying, right? For hello world, I'm asking, is it a closure? Did you see hello world? We are not returning, right? So it's not a closure, none. Whereas for this one, it is saying, yes, it's a closure. It is giving a closure object. If you want further, we can analyze the details of it. But so you understood if you want to check something is a closure or not. And from outside, you can check, hey, whether this outside function is closure or not. It also you can check. It says no. Means the outside function is not a closure. This hello world is not a closure. So the inner function which was exposed to the outside, that is called as a closure. Hope now you understood what is the exact meaning of closures. So fine. So in total, so we have seen like different kinds of functions. So starting from say like ordinary functions, if I can count on. So we initially started with the functions without arguments, then functions with arguments, functions with arguments and returns. And during the return, what is the unpacking? Then overwriting. Python don't have like overloading. We have overwriting and default arguments. Whenever you have like multiple things, if you want to say default arguments, I told during the default arguments, you need to be taking care of memory leakage issues. Then we have like variadic functions, I told. So variadic functions can be variable arguments, which is like a star args. And for variable keyword args, we have like KW, star KW args, I told. Then like we have variable scoping. So local and global. Then after that, I told there are 4 things, LEGB. So local enclosed, so local, So enclosed. So enclosed is not there in Python 2. So in Python 3 it is. Then we have global. So and like built-in scope. So these are like 4 scopes you have totally. Then I told about the recursions. So recursions, in that control recursions, infinite recursions, and like mutual recursions. What is the recursion limit? How to increase it? I told. Then like in the lambdas we discussed. So lambdas are like anonymous functions. So these are called as also called as anonymous because so they don't have a name functions. So how to use it? Primarily when you go with higher order functions, we use it. I told how to use zip. So filter, map, and reduce. From Python 2, it was reduce function. It was moved to functools in Python 3. It's no more a built-in function. So then partial functions, how to implement. So using functools. Then I told like inner functions and local versus non-local. So non-local means one level above. Global means to the global scope. Then like I told closures. And based upon these closures, we have something called as the decorators. So decorators we have.